our inequalities and intervals. The good thing is we're not going to have any of those really crazy graphs that we have to focus on. It's either going to be your arrows pointing out or your arrows crossing, depending on what's happening. So let's just start by wrapping our brains around a simple absolute value equation, inequality. So if we had the absolute value of x is greater than 4, what does absolute value mean again? The distance something is from 0, right? So if we quickly just make a rough number line, throw 0 in the middle. Come on, I know. There we go. So is the number 1 on the number line a distance greater than 4 away from 0?
No.
No. Is 2?
No.
Is 3?
No.
Is 4?
No.
4 isn't, but 4.0001 would be, right? So everything to the left of 4 would be a distance greater than 4 away from 0. So we're going to put a parenthesis, and then I'm going to shade everything to the right. Yeah?
Yeah.
Okay. But then remember, on the number line, we can go in the negative direction and still get the same distance, right? So what number in the negative direction do I need to start at so that my distance is more than 4 units away?
4.
Negative 4, right?
Yeah.
So parenthesis, facing to the left, shade everything to the left.
So even though it would be like x, like you would see that, and it would be x is greater than like -4.
Not x is greater than, x is less than.
Oh,
we're going in the less than.
It would be a negative x.
Right. So now, how would we write this graph in interval notation? Julia?
Negative infinity, comma, -4.
Mm-hmm.
U,
Good.
parentheses, 4,
Good.
positive infinity.
Perfect. Okay, so that would be my interval notation. So if we think about this, what's really happening when I have an absolute value equation or inequality, I end up with x has to be less than -4 or x has to be greater than +4. So think about positive, negative cases. What happens for my positive case? The absolute value just goes away. Does everybody see that? But then what happens when I make the negative case? What happens to your sign?
Flip it.
We have to flip it. So we're still going to do positive, negative cases like we were doing with equations. It's just when we do the negative case, we have to remember to flip the sign. Another important thing to remember is when you have a greater than sign, so greater, I'm going to keep reading it as such. I'm going to keep saying the word greater, because a greater than sign is always going to be an or inequality, which is a union of two things. So greater, get that in your head so that you're hearing it. Greater, not greater, greater. Okay? Now the beauty of the absolute value is because we are talking about something being a distance away from 0, it has to be symmetric on both sides of 0. So we're never going to get those cases. Can I erase this?
Yeah.
We're never going to get those cases where we had an or and we had to do something like, I had 3 here and 4 here. We had overlaps so that I would have all real numbers. Or if my arrows were facing the same direction, then it would be from 3 up to positive infinity, like we had to do in 2.5. Remember those problems where they were special cases? So the nice thing about absolute value is it will always be symmetric so that you're not going to have anything crazy like that. So let's flip the sign. Let's make it the absolute value of x less than 4. So now we're talking about, well, what numbers have a distance of less than 4 units away from 0?
0 to 3.
So 0 up to 4, right? And 0 down to -4. So it's going to be everything in between. Aren't all numbers inside of this shaded region a distance less than 4 units away from 0?
Yeah.
Yes. Okay. How do I write this in interval notation? 2, 4 with parentheses. Good. Okay. So again, if we think about how do I write these as inequalities, well, this shaded region going from 4 would be x is less than 4. This shaded would be x is greater than negative 4. So notice your positive case. What happened? You just eliminated the absolute value signs. But what happened to the negative case? You had to flip the sign. Okay? So your less thans end up being ands. So less than. So that's what I always think in my head. I hear it. You hear it? Less than. You go down to the south, less than. Not less than, less and. Okay? So whenever you have a less than sign, we're looking for the intersection of the two inequalities. Okay? So the first thing you need to decide, do I have a greater than or do I have a less than? If it's greater, it's going to be a union, so you're probably going to have a U in your answer. If it's an and, a less than, then you're going to have something in between two numbers. So your answer will end up looking something like that. Okay? Or brackets if it has an equals to. All right, so let's actually do a problem. Here we go. We're going to do a few, and then we'll go over our special cases, and then that'll be it. So first one's up. Absolute value of x plus 3 plus 5 is less than, less and you keep saying it so you hear it in your head when you are looking at it, 12. So before I can do anything, we have to get the absolute value sign all by itself, which means I have to move the 5 over first by subtracting it. So now we get the absolute value of x plus 3 is less than 7. So now I can make my two cases. My positive case, just eliminate absolute value. X plus 3 is less than 7. Negative case, x plus 3, flip your sign, make your 7 a negative 7. Okay, those are easy calculations. We get x is less than 4. X is greater than negative 10. So again, I'm a visual person, so I like to see it on a graph. I'm going to put negative 10 on the left, 4 on the right. If it's a less than, that means it's an and or an or. And, so that means I'm looking for the intersection, which is just going to be everything in between these two. So parenthesis, parenthesis, shade everything in between.
So, what if you didn't flip the sign at the x plus 3 and 7? Like, what if you did
Right
it
here?
at the beginning? You see what I'm saying? Like, could you do the negative part in the beginning of the equation?
No, you have once you only start separating it once you have nothing after or before your absolute value sign. Okay? You'll get the positive if you do that, the positive number will be correct, but the negative won't. So you only will get part of it. All right, so interval notation, that's just going to be a parenthesis negative 10 up to a parenthesis 4. Okay? All right, let's do the same problem but flip the sign. So just rewrite that, flip your sign the other direction. Oh, I'm adding an equals to too, why not? Let's really step up our game, turn that into a bracket. Okay, so again, before we can split it up, we have to get the absolute value all by itself. So that gets us with the absolute value of x plus 3 is greater than or equal to 7. So greater means we're doing a or, which means my answer is going to have a union of two intervals. So positive case, it's just x plus 3 greater than or equal to 7. Negative case, x plus 3, flip your sign, make your 7 a negative 7. So that gets me x is greater than or equal to 4. X is less than or equal to negative 10. Which is what we had before. It's just now our inequality signs are going in different directions. So on my graph, if I have to be greater than 4, my shading's going to go to the right, with the bracket. At x is less than or equal to negative 10, my shading's going to go to the left, the bracket, which is a union. So we got to marry together the left with the right.
Infinity for like 10,
Yep.
union,
4 to infinity. Right. Good. Okay. And like I said, there's not going to be any of those crazy ones where you're overlapping, the arrows are going the same direction, because it has to stay symmetric, because we're talking about distance away from 0. Okay? Yes?
Are there any exceptions where like it'll look like this, but say it's an and problem?
No. Okay. All right, so we think we got this, so we can do the special cases. All right, let's jump to the special cases. So first special case, absolute value of x is greater than or equal to negative 4. So remember our special case with equations, when we had a negative 4, we just went right with no solution, right? Because we knew that absolute value can never be a negative number. But that's not true for inequalities. So now let's think about this. What is this telling me? I am looking for a number whose distance away from 0 will be greater than negative 4. Will that ever not happen? Think about distance. Distance is always positive, right? Or think about, think about absolute value. Whenever you put a number into absolute value, doesn't it always pop out as a positive? Right? So isn't it true that a positive will always be greater than or equal to negative 4? Yes. So since I have my positive number being greater than or equal to negative 4 always, this is going to be a case of all real numbers. So you got to be careful with the negatives. You can't just jump to the conclusion of no solution like we could with equations. If I flip the sign and do the absolute value of x less than or equal to negative 4, could that ever happen? No, I'm never, ever, ever going to have a positive number that is less than negative 4. So this would be the case of no solution. Okay. And if the third case, if we had the absolute value is less than or equal to 0, what's that going to be? What number has a distance less than or equal to 0? 0. So you would just end up with x equals 0. Okay. All right. So if you have zeros in there, you got to rethink about those. If it was, let's think about this way. Let me erase this for a second. If it was the absolute value of x is greater than 0, so think about this. What numbers have a distance greater than 0 units away from 0? All of them, right? So that would be in all real numbers. Okay? So you just kind of have to think about it that way. All right. Huh? Yeah, because if you think about it number line wise, does 1, I didn't write a 1 there. Is the absolute value of 1 greater than 1?
Yeah.
Yeah. 2, 3, 4, yeah. It would be all numbers except 0, wouldn't it? So it wouldn't be all real numbers.
Yeah, that's right. Okay.
So it's everything excluding 0, right? So how would we do that? We would. Yeah. Union. If it has the equals to, Ethan. Yeah. Thanks.
I couldn't tell if it was like if I was going crazy. I didn't want to. I was just like,
Nope.
is 0
Nope.
not like a number?
No, 0 is a number. Yeah. So that would be all numbers except for 0. which is how you would write it out in interval notation. If it had the equals to, then that would be all real numbers, right? I don't think there's anything that crazy in your homework. Okay, so you have the rest of the time till 10:22.